another Science in Pajamas. I know. I'm kind of trying to do multiple ones in a day today. Yeah, just trying to get things done. Because why not? Alright, so it's summer. I can actually get a lot of these and crank them out right away. So it's all good. Today, we are going to talk about scientific notation. Now, what scientific notation is, it's a great way to write really, really, really big numbers or really, really, really small numbers so you don't have to deal with a whole bunch of excess zeros. It's also really good if you're worrying about significant figures, which we're not going to talk about in this video. We're just going to talk about what they are and in terms of scientific notation and how to write them. Now, like we said, a way to write really big and really small numbers. So let's say maybe you're dealing with a number like that is a really big number. And it's very easy to kind of miscount or forget some of the zeros or write it incorrectly. And it's just, a pain to deal with something that big. So what we will do is we're going to put that number into scientific notation, which is a lot easier to write out, to work with, to remember, all that good stuff. Now, first thing you have to know is that scientific notation has a few basic parts. You have your number times 10 to some kind of exponent. All right? Very easy formula. So for this one, I'm going to actually rewrite that up here. 10 to an exponent. We always want to move, all we're doing here is moving the decimal point. That's all we're doing, not too hard. We always want to put it so that there's generally one or two numbers. Generally one. I have seen it where there's two, but generally where there's one number in front of the decimal point. Now, right now, our decimal point is all the way at the end. How do I know that? Because I don't see it. Whenever you don't see a decimal point, it's assumed to be at the end of the number. Now, if I want it to be, instead of after 1, 12, 13 numbers, I want the decimal point after just one non-zero numeral. So that means I want to put it right after the 1. Because when I do that, then I'm left with 1.8. We're going to get rid of the zeros. We're going to get rid of them. But we're not going to change the value of it. So what I'm going to do is I'm going to move my decimal from here all the way over to there. Because we want to simplify it. We want to make it simpler to look at, to work with, to write out, simpler to understand. Now remember, general formula, number times 10 to an exponent. We have our number, 1.8, because I'm moving the decimal from all the way at the end to right here behind the 1. So that we have one number, one non-zero numeral in front of it. So 1.8 times 10. Question is, all right, what's the exponent? Here's a nice easy thing. The exponent is the number of places that you move your decimal. So start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our exponent is 12. Now you can have positive and negative exponents. And there's this whole way to think about it in terms of, which way are you moving the decimal point. I'll give you the easiest way to figure out if your if your exponent should be positive or negative. Your starting number. Is it bigger than 1 or is it less than 1? This big monstrosity of a number is definitely a lot bigger than 1. Anytime it is bigger than 1, you have a positive exponent. So 1.8 times 10 to the 12th. You just write it like that. Or if you really want to a positive 12. Doesn't matter. Just make sure you don't write negative. It is positive. A positive exponent means that you are going to move the decimal point a certain way when you put it into and out of scientific notation. So far, so good. All right, let's give you an example of one that would have a negative exponent. So I'm going to use 0.0000000031. I think we can all agree this number is less than 1. It is 0.0031. This number is less than 1. This is what I meant when I said bigger than 1 or less than 1. Bigger than 1, positive exponent. Less than 1, negative exponent. All right, so let's figure this out. We want to move our decimal point so that there's only one non-zero numeral in front of it. Well, that means we want to put it right here between the 3 and the 1 so that our number would be 3.1. Look at it. One non-zero numeral in front of it. Then let's continue on with the formula times 10. We got to figure out our exponent now. Again, just like before, it's the number of places that you move the decimal point from where you start to where you end. 1, 2, 3, 4, 5, 6, 7, 8, 9 to the negative 9th. That negative number tells me which way to move my decimal point when I take it out of scientific notation and allows for me to remember that it's going to be a number that is much smaller than 1. So negative exponent, smaller than 1. Positive exponent, bigger than 1. So far, so good? All right, we'll do a couple more examples, then we'll flip it and talk about taking numbers out of scientific notation. All right, so we have, let's see, 7, 3, 2, 0, 0, 0, 0, 0, 0, 0, 0. All right, let's take a look at these. Again, same formula, a number times 10 to an exponent. We want to move our decimal point so that there's only one non-zero numeral in front of it. Now, here are my non-zero numerals. So that means I'm going to want to put it right here. So it's 7.32 times 10. And now the exponent is how many places did I move my decimal point? Well, I don't see my decimal point. That means it's at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times 10 to the 10th. And it's a number that's bigger than 1, so I'm going to leave it as a positive exponent. All right, down here. Let's put this one into scientific notation. That's my only non-zero numeral. So I can put it as 1 or 1.0. Again, we're not worrying about significant figures at this point. So my only non-zero numeral is this 1. So I'm going to put the decimal point behind it, 1.0 times 10. And how many places did I move the decimal? Which right here, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And my original standard number, it's in standard form, it is smaller than 1. So that means it's going to be a negative exponent. All right, so hopefully that helps. We're going to now talk about how to take the numbers in scientific notation and put them back into standard notation, standard form. We have 6.5 times 10 to the 12th. All right. So now let's put this back into regular formation. We're actually going to do it just like we did before, but backwards. Positive exponent tells me my number is going to be bigger than 1. So that actually tells me kind of how to start. I'm going to write the 6 and the 5. Bigger than 1 means I'm going to want to move my decimal point to the right. Because if I moved it the other way, all my zeros would be in front of the 6 and 5, meaning that it's going to be smaller than 1. I want the zeros behind the 6 and the 5. So I have to move my decimal point 12 places. It's between the 6 and 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just like we did with metric conversion, we're going to fill in our zeros. Don't want those looking like decimals. All right, so that's my number in standard notation. Now what if I have 3.9 times 10 to the negative 11th? That negative 11 tells me that my number is going to be smaller than 1, which means when I fill in my zeros, the numbers are going to go in front of the 3. So I'm going to put the 3 and 9 all the way back here. Because I know with the negative exponent that the zeros have to be in front of the 3, in front of my numbers, and that means that I have to move my decimal point to the left. So how many places do I have to move it? 11. So the decimals start off between the 3 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just like before, fill in our zeros. 1. There we go. There's our number back in standard notation. Let's do one more example of each one of these, positive and negative, and then we'll call it a day. So we have 8.5 times 10 to the 15th. Why not? And we'll do 8.5 times 10 to the negative 15. Dun, dun, dun. So if you notice, the only difference between these two numbers is the sign of the exponent. We have a positive exponent, meaning our number in standard form is bigger than 1, and a negative exponent, which means our number in standard form is less than 1. So let's go ahead and get started. 8.5 is a positive exponent, so that means that the zeros are going to come behind the number. So I'm going to write the number first, 8 and 5, and now I have to move my decimal point 15 places to the right to get those zeros behind it in order to make it a larger number. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. There we go. Now let's do the same thing, but with this one, which has negative exponent. Negative exponent means that our number is going to be smaller than 1. That means that all those zeros that we want to fill back in are going to have to go in front of the 8. So I'm going to write the 8 and 5 over this way. And this time I'm going to move my decimal point 15 places to the left. Fill in my zeros. It's a big difference in the value of those numbers. This is why it's good to pay close attention. And before any kids are like, but Miss Komar, does it really actually matter if I make it positive or negative? Yes, it does. Let me ask you this. Would you rather receive this much money or would you rather receive this much money? Those signs matter. Positive exponent versus a negative exponent. The signs matter because they do talk about the value of this number. All right, so I think we're going to call that for the day. That's probably going to be my last video for today. I think I've made 4 of them at this point. So you guys stay awesome, stay amazing, stay fantastic, but most importantly, stay safe and stay healthy. All right, you guys. Until next time, take care of yourself.